Welcome to A2 level computer science, and we are on chapter number 1. And the name of our chapter number 1 is data representation. Basically, it is chapter number 13, but according to A2, it's our first chapter according to the syllabus. And we have done non-composite data type. In non-composite, we have done enumerated pointer data type. Today, we are going to continue with the topic of file organization and access. In file organization, we are discussing about the sequential files. But today we are going to start the new topic that's called file access. So file access is just like our file organization topic. Here we have multiple options. Again, we have sequential access and direct access. Let's see how it works. There are different methods of file access. The method used to physically find a record in a file. Yes. This time, we are going to look for the file. Like if I said in your laptop, I need the chapter number 13, A2 notes. So you said, sir, okay, I will check my folders and I will get back to you. You're going to click on my computer. Then you're going to click on partition, like you click on E partition. Then you click on your folder name, Aisha. Then you click on computer, physics, and chemistry. So you click on computer, you have 3 folders because you're taking 3 subjects in A levels. So you have to go to computer. When you go to computer, you see there is a chapter number 13A notes. So you just click on 13 and you will get the notes. So look, you work in a proper sequence. So this is the thing in file access, we are going to work in a proper cycle. We are not going to do or pick anything directly because there is a pathway. In computer, every file have a particular location or have a proper pathway. It is just like your home address. Like if I'm going to send you a courier, so I have to tell the company about your address. If I'm not going to tell the address, definitely the courier will not reach to your destination. So I need to write down that I live in house number 45, Gulshan Iqbal, 15A4, whatever. The address is very, very specific. Just like that, in order to search for a proper record or for any file, the computer have to work in a proper sequence. So that is how we are going to get access to our file. So we will consider 2 of them, sequential access and direct access. So if we need to access our file, we have 2 different strategies, sequential access and direct access. Let's see the first one, sequential access. Hello, Mustafa, how are you?
Fine, sir.
You forgot the class time?
No, I was updating my device, so like when I was supposed to join, it was like off the laptop.
Okay, no problem. I just started the lecture, doesn't matter. Okay, so our first topic is the sequential access. The sequential access method searches for records one after another from the physical start of the file until the requested record is found. So again, we have some stack of files. Let me draw some stacks. You can see stack 1, stack 2, like that. So it is just like arrays, but it is not a topic of arrays, okay? Mustafa, you asked me in the last lesson, remember? So
Yeah, I do.
we have file A, we have file B, we have file C, we have file D, and file E. So while we are going to work on a sequential access, the computer have to search one after another. So computer starts searching from the position number 0 or location number 0. So on location number 0, we have file A. Our destination file is file number D. So the computer works in a proper sequence like this. Then 1, then 2, and then finally, we search for our specific record, and that is our D. So it means that in sequential access, the computer or the method is going to access the files one after another. Or a new record can be added to a file. This method is used for serial and sequential access. So if you're going to record any new thing, just like right here, I added a new record. This is fifth. So after E, we have F. See this. So in F, we have the record, and look, you have to notice that the F is added in the last. So it means the computer is going to follow a proper sequence. So it is not possible that the record will be added here, because whole sequence will be disturbed in this way, right? So this type of access is called sequential access. Now we have another access called direct access. The direct access method can physically find a record in a file without other records being physically read. So in direct access, the strategy is very easy. If we are looking for D, so the computer is going to pick the file D directly on position number 3. Right? So it means the direct access is quicker method. It works quickly. So it is not going to make you stay for some time like sequential access, because in sequential access, we have to wait because the computer is going to find out the specific record. Both sequential and random files can use direct access. This allows specific records to be found more quickly than using the sequential access. Yes, it is mandatory for computing nowadays that the users are very restless. Like me, you, everyone wants a quicker thing. Like if you're going to search anything on a Google responds us in 0.3 seconds. So how does Google works? It is not following sequential. Yes, it is going to use a direct AI method. So we all want to search the records or any file as quick as it can. So mostly the direct access will be in command. Direct access is going to be picked by sequential and the random files, because they are going to search the particular file without wasting the user's time. There's one more thing, guys, called random access. For random access file, a hashing algorithm is used on the key field to calculate the address of the file location where a given record is stored. So yes, there is a proper algorithm in order to locate the address of the file. Look, I have written down 6 addresses starting from 0 till 5. It means it is 6 in numbers. So the random access is going to calculate the location of your address. It is also a very, very quick method. So if you are going to use any random records, so a random access will use, it is going to find out the file with the help of the location and then address of the memory. So this is how we have 3 types of file access. Now, what I want, let me describe you the task. You need to use a table, guys, or draw the table like this. In the first table, you need to write sequential. In the second table, you need to write direct. And in the third table, you need to write random access. After writing down the 3 columns, you have to write down 2 points of each as a difference. Is it okay, guys?
Okay, sir, but I have one question.
Please.
In sequential access, since you said the device goes by like 1 letter at a time, so A, then will check B, C, D. But what if there's like a number? Will it go like full letters first, then numbers?
Basically, they are going to search with the help of the location address, like 0. 0 is the location address of the file. So whatever the data is stored on the location 0, like A, so it is going to search for that record. So it is not our D, because the computer is finding D. So it moved to the second or first location. According to my diagram, this is number 1. So on number 1, what is the file name? B. B is located. So in this way, it is going to search one after another as a part of the location first, and then it moves to the file.
Okay, I see.
Okay, so guys, you have a task. You have to write down two differences of all three topics. You have to draw the table and send me the picture in the group. I'm waiting. So our new topic is floating point number representation, as we are on the topic of data representation. So how do we represent the numbers? Are called floating point. So there is a formula for calculating the floating point. The formula is m into 2 power e, or exponent, you can say. E is exponent, right? So m into 2 power e. This is a formula. What is the meaning of m? M is mantissa and e is the exponent. So we have two things in this formula in order to calculate floating point. M is mantissa and e is the exponent. And this scenario is called binary floating point representation. It means that in this topic, we are going to represent binary, right? Just like we have done the conversions, binary to denary, denary to binary, binary to hexa, just like that, we have a topic of floating point. So in our examples, we will assume a computer is using 8 bits to represent the mantissa and 8 bits to store the exponent. So guys, it means for mantissa, we need to make a register of 8 bits, right? And for exponent, we are going to again make a register of 8 bits, right? So we have to make 2 registers, and every register is of 8 bits. Now, the topic, example number 1, we have a topic converting binary floating numbers into denary. Just like we have already done in the last session in AS, how to convert binary to denary. So remember, guys, we draw a register. In that register, we draw 8 bits register. Just like that, we are going to draw the same thing. Okay, so we have a question. We have a question here. First, you see the question. I'm going to write it down for you guys. Okay. So the question is, very carefully, look very carefully, guys. We have a question like 0.10111010, right? And you have a separate register. Look, again, 0.00000100. So which is for mantissa? This one is for mantissa, and this one is for exponent, right? Ex, exponent. So this is your question in binary, right? So one more thing you have to understand, guys, a very important thing. Maybe in your exam, you will not get the registers like that. So you have to draw the registers by your own. So for mantissa, you see, you need to write down the values in fraction, like 1 over 128, 64, 32, 16, 8, 4, 2, and -1. So did you notice that this thing is moving in the reverse order? And
Yes.
it is in fraction. So this is the point you have to be note down. In mantissa, you have to write down 128, 64, 32, 16, 8, 4, 2, -1. But it is always in a form of 1 over, like 1 over 28, 1 over 64. So it means mantissa will be written down in a form of fraction. But here in exponent, you see the order is perfectly fine. It means the order is in a regular form, like 1, 2, 4, 8, 16, 32, 64, -128. And after -128, you see 1 over 28, 1 over 64, 1 over 32, 1 over 16, 1 over 8, 1 over 4, 1 over 2, and -1.
Sir, I have a question.
Yes.
Why do we have negative signs in this?
Because
Shouldn't it just be like,
because in these questions, if you get the first bit here, this one, if it is 1. So remember, I told you in complements topic that if it is 1, it is a negative number. In complement, do you remember the complement topic? 1's complement, 2's complement. Yes. So what is 2's complement job? 2's complement job is to convert the negative number into positive or vice versa. So if you have any value, even in exponent here, you see negative 28, 128, and here you have negative 1. If you have any value which belongs to the negative, so you can easily sort it out. That is the reason you got negative 1 and negative 128 in exponent.
okay.
Okay, let's move on. So first, what we have to do, we need to draw the registers. The registers first for the exponent. For the exponent, we are going to write 1, 2, 4, 8, 16, 32, 64, negative 128. This is a very regular practice. But after negative 128, you have to write 1 upon 128, 1 over 64, 1 over 32, 1 over 16, 1 over 8, 1 over 4, 1 over 2, and finally negative 1. This is the mantissa. Now, the question you see here is 0, 1, 0, 1, 1, 0, 1, 0. This is from mantissa. So what you have to do, guys, you already know. You need to pick only the values which are having 1. Look, which are having 1. 1. And then 1. So you need to write down all these values like this. So here you see for mantissa, first you pick 1 over 2, then 1 over 8, then 1 over 16, and then 1 over 64. Right? After adding all these values, you will get the answer. So the answer is 45 over 64. You need to find out the LCM, then you need to do the calculations. In the early stages, you already know how to solve this. So you got the answer, 45 over 64. Is that okay? After this exponent, you need to pick again the same thing. The same thing. It's a very regular practice, guys, that you need to only pick the number which are having 1. So in exponent, can you tell me which number having 1?
4.
4. So look, you need to write exponent value 4. What is the formula? Formula is very simple. Right here, you can see mantissa into 2 exponent. Mantissa into 2 exponent. So you need to write mantissa value. What is the mantissa value? 45 over 64. Into 2. So you need to write 2. What is the value of exponent, guys? 4. Look here, guys. It's 4. Exponent. Isn't it?
Yeah.
Yes. So for exponent, you need to write. So you need to put the values like 45 over 64. You have to write it down like this. And 2 power 4. So if you are going to multiply 2 4 times, you will get 16. And after solving it, you will get the denary value, 11.25. So look, your answer is in point. So this is the floating point topic, 11.25. So you need to do the calculations as per your requirement. 0.7 and 0.3125 multiplied by 16, you will get this answer. Is that okay?
Yeah.
Now, what do you have to do, guys? First, you need to write down the formula, mantissa into 2 exponent. And if you wanted to write anything which thinks it is useful for you, you are free to write. And then you have to do this example number 1.